Hello, I'm Harshada Gurav. Today I'm here to discuss about classification of memory systems in computer architecture. So let's first understand what is a memory system. Computer memory is just like our brain. It is used to store both information and instructions. It is a data storage unit or device where data to be processed and instructions that are required for processing that data are stored. It can store both the input and output. So while understanding memory system, it is crucial to understand different types of memory for efficient system design and performance optimization. Let's see that. This is a rough classification of memory system. Memory system is basically divided into three types: volatile versus non-volatile memory, random access memory versus direct sequential access memory, and last one is read-only memory, that is ROM, versus random access memory, that is RAM. So let's see one by one. First one is volatile memory versus non-volatile memory. Volatile memory is a type of memory in which data is stored temporarily. That is, it is used for temporary storage of data. On the other hand, in non-volatile memory, the data is stored permanently. In volatile memory, we require a continuous power supply to retain the data. We cannot retain the data once the power supply is turned off. While in non-volatile memory, we can retain the data even when the power is turned off. In volatile memory, the program's data are stored which are currently in process by the CPU. While in non-volatile memory, any kind of data which has to be saved permanently are stored. In volatile, processor has direct access to data, while in non-volatile, processor has no direct access to data. Also, volatile memory has a huge impact on system performance. On the other hand, non-volatile memory has a huge impact on system storage capacity. Non-volatile memory has more storage capacity and it is less costly, while volatile memory has less storage capacity and it is more costly per unit size. The examples of volatile memory are chemostatic memory, CMOS dynamic memory, while the example of non-volatile memory are read-only memory, that is ROM, then magnetic disk, CD-ROM, DVD, flash memory, resistive memory, etc. Now, let's see the second one, that is random access memory versus sequential access memory, or we can say direct access memory. So, in random access memory, the amount of time needed to access memory is not dependent on the storage location. While in sequential or direct access memory, the memory access time depends on where the data is stored or where the data is located. In RAM, memory access time is less, while in sequential access memory, the time required to access the memory is more. Random memory access has volatile memory, while the sequential memory access has non-volatile memory. In random access memory, each storage location in the memory has a unique address and it can be accessed independently of other location. That means we can randomly access any data because it has its own unique address. While in sequential access memory, the memory is organized into units of data and that are called records. So these records are accessed sequentially. We cannot just randomly pick any record. The example of random access memory can be semiconductor devices, and for sequential or direct access memory, the best example is magnetic tape. Now, let's see read-only memory, that is ROM, versus random access memory, that is RAM. So, ROM is a non-volatile memory that could retain the data even when the power is turned off, while RAM is a volatile memory that implies it can store the data as long as the power is supplied. In ROM, only read operations are supported, as its name suggests read-only memory, while in random access memory, both read and write operations are supported. The, the CPU cannot easily access the data that is stored in ROM, while in RAM, CPU can easily access the data. Read-only memory, that is ROM, is used to store firmware, BIOS, and other data that needs to be written. Here, BIOS means basic input system. So, where the data need to be written or need to be stored permanently, read-only memory is used. While uh, RAM memory is used for the temporary storage of data currently being processed by the CPU. Read-only memory is much slower than RAM, while RAM is high-speed memory. So this is a classification of our memory system. Thank you.